Hello guys, so today we are here to solve our daily lead code challenge for the day. The challenge is maximum difference between increasing elements. In this challenge we are given an integer array nums, okay, and the size of this integer array is n. Obviously it is a zero index integer array, and the problem is asking us to find the maximum difference between the nums I and nums j. Okay, so the problem is asking a very simple thing, but the constraint is that I should always be less than j. The index I should be less than index j. Obviously, both I and j have to be, greater than equal to 0, and they both have to be less than n. But the additional structure is that I should be less than j, strictly less than j. Okay, and nums I should also be less than nums j. We have to return, you know, following these constraints, we have to return the maximum difference. If no such I and j exist, return -1. Okay, so the default value of maximum difference is -1. Okay, so let's do this calculation. So first of all, we will find the length of this given array nums dot length. Okay, and max diff is the default value, as we understood, is -1. So now we will just do for int I is equal to 0, I less than n minus 1. Okay, what the problem is asking, we'll try to do whatever the problem is asking. Now we are going through each and every element from the 0th to the n minus 1th. Why we are going till the n minus second element? We are going till n minus second element because after n minus second the n minus 1th element is there, and that will be our jth value. So int j is equal to I plus 1, and obviously j will vary till less than n, plus j. Okay, and then what we will do, if um, so nums of, obviously j is greater than I, because j, the least value that j you know can assume is I plus 1. So for sure j is greater than I, but we need to put a check for this condition that nums of j should be greater than nums of I, because this is what is being said in the problem statement. And after this, and max diff is less than nums of j minus nums of I. Okay, so here we'll update our max diff nums of j minus nums of I. Okay, so we'll just return this max diff. Okay, so with this condition, let's run this. It's accepting. So it's on submitting, it's passing all the test cases, though the performance is not to our liking. And definitely we can make out that this is big of n square time complexity. Why? Because it's using nested loop, and for every I we are traversing the inner loop, you know to the big order of n times. But can we make this simple? Obviously, we can do one simplifying thing over here. We can remove this thing completely. Okay, and use our math.max diff. Okay, but this is not going to bring out uh, you know a revolutionary change. What we need to do here, though this is correct, and let me show it to you how it is correct. So by running this, it should accept. Yes, it's accepting. Let me submit it, and this should be passing all the test cases as well. Yes, it's passing all the test cases. but there is no radical benefit. I mean to say, it's following the same paradigm. This is just, little small cosmetic change. In order to have a, bigger change, we should rather aim at having single pass solution to this. How can we be having a single pass solution to this problem? In order to solve this problem in single pass, what we will do, that we will, get rid of this inner loop. Okay, so if we get rid of this inner loop, I think we can copy this line. This line will be of use to us. Okay, and we will, remove this. Now see what we were doing. We were finding, in order to find max diff, we want to have the current min. Okay, so let's declare one variable called current min, and current min is equal to nums of 0. The first element of the array is nums of 0. Okay, and we will start traversing the array with the first element, and we'll be going till the last element. To go till the last element, we need to do I less than n. That's how we'll be going till n minus 1th element. And after going to the n minus 1th element, what we will do, that we will put a check if nums of I, okay, nums of I is less than the current min. Okay, then what we will do, we will update the current min. Okay, is equal to nums of I, and else what we will do, so else, see, else has, two conditions. So else what we will do, if, so first thing that we want to check is that, nums of I is greater than current min. If it is greater than the current min, then what we will do, we will, use this same line, max diff, and instead of using this j and I, because now we are only using this single loop and that index is only I, so we'll be, doing this current min. And let me just run this. Perfect. Perfect. So you must understand few things. At every step, I at every iteration, either we are getting a new value for the current min, or if the current min is less than the current element, we update the max diff subject to the condition, that the current diff is greater than max diff. So if this is being followed, then we'll return the max diff. Okay, perfect. So I hope you liked this solution. With this, I'm thanking you. Thanks a lot. Happy coding. Best wishes.